You hear a ton about the power of AI, right? But there's this other conversation that's getting louder. What's its environmental price tag? It seems like a simple question. How much does one AI prompt cost the planet? But getting a straight answer has been, well, pretty much impossible. So today, let's dig in and figure out what's really going on.
So let's just get right to it. When you type a query, ask a question, generate an image, what's the real cost? Not in dollars, but in energy, in water, in carbon. You'd think there'd be a simple answer, but the truth has been a bit of a mess.
I mean, just look at this. The public estimates for how much energy a prompt uses are all over the place. We're talking numbers that are different by an entire order of magnitude. Some reports say it's around 3 watt-hours, while others, even from the heads of AI companies, say it's more like 0.3. With that kind of difference, how is anyone supposed to know what the real impact is?
So what gives? Why the huge gap? Well, the issue isn't really about someone's math being wrong. The real problem is that everybody has been measuring different things. It's like everyone's running a race, but they all started at different lines. There's just been no common standard.
Okay, so if the old way of measuring is the problem, what's the solution? Well, it's pretty clear we have to rethink how we measure this stuff entirely. We need a more complete picture, one that looks at the whole system, not just a tiny, isolated piece of it.
And this slide really lays it out. See, most of the old numbers just focused on the AI accelerators, the powerful chips doing the hard math, and they were often measured in a perfect lab setting. The comprehensive approach, which comes from new Google research, measures the entire system, the full stack as it runs in the real world. That's how you get a number you can actually trust.
The key idea here is something called the measurement boundary. You can think of it like drawing a circle. Everything inside the circle gets counted, everything outside doesn't. If you draw a really small circle, you'll get a really small number, but you'll also be missing most of the story.
Now this is where it gets really interesting, because you can see everything that was being left out. Yeah, the active AI chips are the biggest slice of the pie, at 58%. But look at the rest. The computer's own CPU and memory, the power burned by machines just sitting idle waiting for a traffic spike, and even the data center overhead like cooling. All of that stuff adds up. In fact, it's almost half the total energy cost.
All right, so with this new, comprehensive, full-stack way of measuring, what is the actual cost? Let's finally put some real, solid numbers on the board.
Okay, here it is. The first big reveal. A median Gemini prompt eats up just 0.24 watt-hours of energy. Remember that 3.0 number we saw at the beginning? This is more than 10 times smaller. But what does that actually feel like?
Let's put it into perspective. A typical modern TV uses about 100 watts. This means a single AI prompt uses less energy than just watching TV for 9 seconds. When you think about the computation happening, that is a surprisingly small amount.
Okay, what about water? That's a huge deal for cooling these giant data centers. Well, the number is just 0.26 milliliters per prompt. Again, sounds tiny, but let's make it real.
What does that tiny number actually mean? It's about 5 drops of water. 5. That's it. A far cry from some of the earlier estimates that made it sound like you were using a whole bottle of water with every query.
And finally, let's talk carbon. Using this full stack method, one prompt gives off a mere 0.03 grams of carbon dioxide equivalent. So the takeaway here is that on a per-prompt basis, the cost is remarkably, almost shockingly small.
But the story doesn't stop there. It's not just about how small the number is today. What's honestly even more mind-blowing is how fast that number is getting even smaller. We're talking about massive efficiency gains.
This right here, this is the hero number, 44x. In a single year, the carbon emissions for a prompt were slashed by a factor of 44. That is just an insane level of improvement in such a short period of time. So you have to be asking, how on earth did they do that?
Well, it wasn't one magic trick. It was a compounding effect. As you can see here, first, just improvements to the software and the AI models themselves created a staggering 33 times reduction in energy use. Then you layer on top of that a push for cleaner energy sources for the data centers. You put those two things together, and boom, you get that incredible 44x reduction.
And the how is really a story of optimizing everything from top to bottom. It's using smarter model designs like Mixture of Experts, which only fire up the parts of the AI that are needed. It's custom-built hardware like TPUs. It's better software. And it's running it all in hyper-efficient data centers. Every single layer plays a part in pushing that footprint down.
Okay, so we've established that one prompt has a tiny impact, and it's getting tinier by the day. So
why does any of this matter? Why obsess over these details? The answer comes down to one simple word: scale.
And this is the absolute key to the whole conversation. Your one prompt is 5 drops of water. Who cares, right? But what about billions of users making billions of prompts every single day? That's not 5 drops, that is a tidal wave. And at that scale, every tiny bit of efficiency has a massive impact on the planet. Which brings us right back to where we started. As the researchers themselves say, we need a standardized, comprehensive way to measure all of this. It's the only way to compare apples to apples, to keep everyone honest, and to actually push for the kind of incredible efficiency gains we've just been talking about.
So we'll leave you with this thought. We know a single prompt's footprint is tiny, and it's shrinking at a crazy pace. But at the same time, AI use is absolutely exploding. So we're in a race. Is efficiency getting better fast enough to stay ahead of that exponential growth in demand? That is the billion-user question.